So there are other mechanisms that he talks about in the book. These aren't thought to be as large a factors of how overpressure is generated. One of them is he calls aquathermal pressurization. This comes from, the radioactive decay of organic materials in the earth, and also the upward heat flow of the mantle. But at the scale of the earth and the crust, that heat flow is actually quite slow. And so the idea here is that there's heat being generated, either from diffusion from the mantle or inherent, as a reaction in radioactive decay. There's heat being generated, and if you have if you have a fluid and you heat it up, what happens? Well, it doesn't. It expands. Okay? It expands. But if it's confined to a volume, a pore, then that in turn increases the pressure. Right? So you have a fluid that's confined, and you heat it up, it increases the pressure due to expansion. Okay. And so, again, this is a possibility for overpressure, but it's not typically considered to be significant because of the time scale at which, diffusion from the mantle would take a very, very long time to have any effect. And same with the temperature increase from radioactive decay. So, and then the last one is, you actually have hydrocarbons being generated in a confined space, right? So, you have thermal maturation of kerogen, which becomes oil, gas, condensate, right? And so you're actually generating hydrocarbons in a confined space, and that can cause a small amount of pressure increase. And so